demand, one of the very few laws in economics, law of diminishing marginal returns, law of demand, law of supply. So very few laws, so that should tell you something. The law of demand just simply tells us that as the price of a good rises, the quantity demanded for that good falls. Notice I did not say that as the price of a good rises, the demand for that good falls. No, and I didn't. I said quantity demand. It's extremely important that we get this out of the way. Demand and quantity demand are two completely different things. Quantity demand is a particular level of demand on a particular demand curve. The demand is the actual curve itself. So real quick, just get that out of the way. Quantity demand refers to the level of quantity demand at a particular price. So at a price of 8 here, 20 boxes of cereal are demanded. At a price of $3.50, 65 boxes of cereal are demanded. Okay. So again, the demand is the entire curve. Quantity demand refers to particular quantity levels from particular prices. So the law of demand just simply tells us that as the price of a product falls, the quantity demand for that product rises, and as the price of a product rises, the quantity demand for that product falls. Very basic. Students get this wrong mostly because they say that as the price of something falls, the demand for it goes up. No. Demand is going to refer to demand increasing or decreasing is going to refer to the shifting of demand up or back. But if we say the quantity demand rises or falls, it means we're moving along the curve. So in other words, if the price of cereal were to change from 8 to 3.5, then we would move along the demand curve down to here. It's not a shift of the curve, it's a movement along. So one of the most important points we need to bring up now is that changes in price, say, of a particular product, do not cause shifts in demand or supply, we'll find out later, of that particular product. In fact, it will be shifts in demand and supply which cause changes in prices, not the opposite. So changes in prices of goods do not cause shifts in the demand for that good. So if the price of cereal were to go down or up, it does not cause a shift of cereal down or up. We simply move along the curve to different levels of quantity demand. Now, we often think about demand in two ways. We think about demand in the context of individual demand. And again, individual demand is going to come from utility functions. It's going to come from maximum willingness to pay. In fact, we'll discuss how the demand curve itself is a representation of maximum willingness to pay. And we can see this if we think about the two types of cereal consumers, people who like cereal and people who love cereal. Notice that people who love cereal have higher demand. Their demand curve is further out. And notice what this means. It means that at the same price, they are willing to consume more cereal than those people who like cereal. So for example, at $3.50, we see that people who like cereal consume 20 units, while people who love cereal consume 45 units. Further, notice that if we just add up these two amounts, we get what the entire market for cereal wants to consume at 3.5 units, which is 65 boxes of cereal, 20 plus 45. Now, what this means is that in order to get the market demand for cereal, I simply add up horizontally my individual demand curves. Now, we've made it a little simpler here. We just have two types of consumers. But if you can imagine that there are a litany of individuals in here with all of their own individual demand curves, and we simply add all those demand curves up horizontally, and it gives us our market demand curve. And so again, we can see that at a price of 8, for example, we would simply take this level of quantity demand for cereal likers, this level of quantity demand for cereal lovers, add those two together, and it would give us our 20 boxes of cereal for the entire market. So the market demand curve is simply an aggregate of individual demand curves. All right, so here's a mathematical representation without the graph. Here I just have a demand function Q equals 100 minus 10p. You actually notice this is the exact demand function I have here. So this demand function here, cereal, which by the way is just the same one as this here, but is this right here, right? 100 minus 10p. I can show you that if I simply plug in values for P, it will spit out levels of quantity demand given this demand function. So for example, if P is equal to $5, 10 times 5 would be 50. So 100 minus 50 would be 50. So if we look at this particular demand curve, if we were to look at a price of $5, we would see that the boxes of cereal demanded at $5 would be 50, as we would predict. Or we could say plug in a price of 3.5, so 3.5. So 100 minus 10 times 3.5 would be 10 times 3.5 is 35. So 100 minus 35 is 65. So Q equals 65. We go back, we can see at 3.5, quantity demand was 65, just as we would predict. So again, we can think about this graphically, or we can think about it in the context of an equation. Either way, it's all basically the same idea. Importantly, the extent that quantity demanded falls relative to price is an important consideration. So in other words, what's the slope, right? So this is one of the reasons why I'm having you consider slopes when we look at linear functions. Because you can imagine that a steep slope or a very flat slope means something in the context of consumers. Given that the demand curve represents maximum willingness to pay, as I've previously mentioned, then having a very steep slope or having a very flat slope for your demand curve must also mean something about the underlying behavior of consumers buying those goods. So think about this in the context of the market for a product like cigarettes, which is addictive, versus, say, the market for tissues, which not only are not addictive, but are not likely purchased by everyone every time they go to the store. So it's a very selective good in that sense, whereas cigarettes are something that when someone who buys cigarettes, they may buy them every single time they go to the store. So I want you to think about what this means in the context of the slopes of the demand curves and what this could mean. Okay, so let's sort of briefly review. The demand curve represents a schedule of prices and quantity demand given a certain level of demand within a market at a given time. It's really important for us to point out that the demand curve is what we call static. It's a snapshot. It tells us at these particular prices what this particular market is demanding. And if anything changes in the market on the supply side or on the demand side, we'll see that the underlying nature of demand itself does not change. Right? At the end of the day, we're always going to assume that demand curves are downward sloping, price on the vertical axis, quantity on the horizontal axis. Okay, we're going to assume that consumers are utility maximizers. Okay, that's what's going to create market demand, is you have individual consumers all trying to maximize a utility. This creates maximum willingness to pay on the consumer side. So maximum willingness to pay comes from utility maximization, and maximum willingness to pay is what defines the demand curve. Okay, each particular level of quantity demand on a demand curve comes with it a maximum willingness to pay. So in this market, 20 boxes of cereal have a maximum willingness to pay of $8. What this tells us is that if you were to charge $8 for cereal in this market, at most you would expect to sell 20 boxes. If instead you were to sell your boxes of cereal for $3.50 per box, you would expect to sell 65 boxes of cereal if you were the only producer of cereal in that given market.